The chain rule for derivatives. What is it? The chain rule for derivatives tells you how to take the derivative of a composed or composite or compound function. That is, a function of a function. Suppose we have a function f of x equals x squared. Then to apply f to any number, we just put that number in place of x. For example, f of 1 equals 1 squared. Or f of 7 equals 7 squared. It also works for symbolic constants or other variables. For example, f of a equals a squared. Or f of y equals y squared. Now suppose we have another function, g of x equals 3x plus 4. If we now apply f to g, we put g of x in place of x to get a composite function, or a function of a function like this. This is called the composition of f and g, and is sometimes written like this. All this means is one function inside another. So if you were to apply this function to any number, say 3, you would first apply g and compute g of 3, which is 3 times 3 plus 4, or 13. Then you would apply f to the result to get f of g of 3 is 169, or 13 squared. Whenever you encounter an expression with parentheses in it, chances are you're looking at a composed function. For example, the following are all composed functions. Sometimes functions are composed more than once. For example, you might have 3 functions, f, g, and h. F of g is cosine g of h is h cubed, and h of x equals 2x plus 1, which gives the composition of f, g, and h as cosine of 2x plus 1 cubed. Other examples are the following. So now let's talk about the derivatives of composed functions. Now that we know what a composed function is, let's take derivatives of those functions using the chain rule. The chain rule says that if f of g of x is a composed function, then its derivative is f prime of g times g prime of x. Or in Leibniz notation, df dx is equal to df dg times dg dx. In other words, we first differentiate f with respect to g, then differentiate g with respect to x, and multiply the results together. To see how this works, let's do some examples. Suppose we have the function f of x equals 3x plus 4 all squared. If we call what's inside the parentheses, 3x plus 4, g, then we have g of x equals 3x plus 4, and f of g is g squared. So in order to get the derivative of f with respect to x, we first take the derivative of f with respect to g, which is 2g. Then we take the derivative of g with respect to x, which is 3. So using the chain rule, we multiply them together, and we get f prime of x is 2g times 3, or 6g, and g is 3x plus 4. Now you might say we could have just multiplied out the 3x plus 4 squared and taken the derivative of that. And you could do that. That's because this is a relatively simple expression. But what if the exponent had been 100? then it would be clear that doing it that way would be extremely difficult. However, using the chain rule would work just like this example here. To prove that we get the same answer, we'll go ahead and multiply it out and take the derivative. Multiplying it out, we get f of x equals 9x squared plus 24x plus 16. If we take the derivative of that, we get 18x plus 24. Factoring out a 6, we get 6 times 3x plus 4, giving us the same answer as we got from the chain rule. Now let's do another example. Suppose we have the expression 5x squared plus 3x plus 1 all raised to the 4th power. So again, what's inside the parentheses is the inner function g, and the outer function is g to the 4th. So the derivative of f with respect to g is 4g cubed, and the derivative of g with respect to x is 10x plus 3. So by the chain rule, f prime of x is 4g cubed times the expression 10x plus 3, which is the same as 4 times the expression 10x plus 3 times the expression 5x squared plus 3x plus 1 all cubed. Now let's do another example. Suppose we have the expression f of x equals the natural logarithm of cosine of x. Again, we have some parentheses. So what's inside the parentheses is the inside function. We'll call that g. G is cosine of x. The outside function is natural logarithm. So f of g is the natural logarithm of g. Now if we take the derivative f prime of g, we get 1 over g, since the derivative of the natural logarithm is 1 over its argument. Now if we take the derivative of g, that's minus sine of x, since the derivative of cosine is minus sine. Using the chain rule, we get that f prime of x is 1 over g times minus sine of x. Since g is cosine of x, this is equal to minus sine of x over cosine of x, or minus tangent of x. Another example. Suppose we have f of x equals e to the power x cubed. Then, since we again have parentheses, the inner function is x cubed, so g of x equals x cubed. And the outer function is f of g equals e to the g. F prime of g is again e to the g, whereas the derivative of g with respect to x is 3x squared. So using the chain rule, we multiply those together and get that f prime of x is 3x squared times e to the g, which is the same as 3x squared times e to the power x cubed. Now, a final example. Suppose we have the function f of x equals tan squared x, which is the same as tangent of x squared. Then the inner function is tangent of x, and the outer function is g squared. So the derivative of f with respect to g is 2g, and the derivative of g with respect to x is secant squared x, since the derivative of tangent of x is secant squared of x. Then using the chain rule, f prime of x is equal to 2g times secant squared of x, which is the same as 2 tangent of x times secant squared of x. Now let's do some examples with three functions. Suppose we have the expression f of x equals the expression 9x plus 2 squared plus 3 all cubed. Then we have three functions. F of g is g cubed. Then g is a function of another function h, and g of h equals h squared plus 3. And h equals 9x plus 2. So f of g of h of x is the expression 9x plus 2 squared plus 3 all cubed. To use the chain rule, we take the derivatives one at a time. F prime of g is 3g squared. G prime of h is 2h. And h prime of x is 9. Using the chain rule, we multiply all those together. So f prime of x is equal to 3g squared times 2h times 9, which is the same as 54 times the expression 9x plus 2 times the expression 9x plus 2 squared plus 3 all squared. So what are we doing? We're looking at a complex expression with parentheses in it, and we are peeling it apart one layer at a time from the outside in, treating each set of parentheses as a function, treating what's inside the parentheses as a variable, taking the derivative at each step, then looking inside the parentheses and continuing on with the same procedure. Keep going until there are no more parentheses. Then finally, multiply all the derivatives together to get the result. So in summary, whenever you want to differentiate an expression with parentheses in it, use the chain rule. First, take the derivative of the outside of the parentheses, ignoring what's inside. Then multiply that by the derivative of what's inside the parentheses. Use the chain rule as many times as necessary to get to an expression that has no parentheses, then multiply all the derivatives together to get the result. Thanks for watching.